What is a fractional equation? A fractional equation is an equation with at least one fraction. We've learned to solve linear and quadratic equations with fractions, but those fractions were the numerical coefficients of the variables or the constants. In this lesson, we shall learn to solve fractional equations with the variables in the denominators. Let's look at a problem. Solve and check. Please notice I have x's in the denominator. When I'm asked to solve this equation, the first step is to get rid of the denominators. Do you remember how to eliminate the denominators when solving linear and quadratic equations? We find the LCD and multiply both sides of the equation by the LCD to get rid of the fractions. When solving fractional equations, we shall also find the LCD and multiply both sides of the equation by the LCD to get rid of the denominators. We shall then solve the resulting linear or quadratic equations following the steps that we have learned for these types of equations. We shall check the proposed solution, and if it checks, we shall write the solution set. Let's list these steps. Steps for solving a fractional equation. First, we shall find the LCD. Next, we shall multiply both sides of the equation by the LCD. We shall solve the resulting linear or quadratic equation. We shall check the proposed solution. It is very important whenever we multiply through by an LCD which contains a variable to check the proposed solution. It is possible that a solution will be introduced into the resulting equation which is not a solution of the original equation. If the solution checks, we shall write the solution set. Let's solve some equations. Here is a list of the equations I shall solve in this lesson. Problem number 1, solve and check. I am solving a fractional equation. I know I want to get rid of the denominators. I need to find the LCD. I will rewrite the problem 2 over, and my denominator 5x is factored, minus 1 over 3 times x equals x over 15. To find my LCD, I look at the factors of the denominators. For numerical factors, I have a 5, a 3, and a 15. The smallest number that 5, 3, and 15 will go into evenly is 15. So I will use 15 for my numerical factor of my LCD. The only variable factor that I have is an x. It is raised to the first power in each denominator, so I only need it raised to the first power for my LCD. Next, I multiply both sides of the equation by my LCD. I will write 15x over 1 since I am multiplying by fractions in my original equation, times 2 over 5x minus 1 over 3x equals, and I will multiply the other side of the equation by my LCD, 15x over 1 times x over 15. Now on the left, when I multiply, I need to multiply my 15x by each of these terms in parentheses. So I will write 15x over 1 times 2 over 5x. When I multiply my 15x times the minus 1 over 3x, I will say a positive times a negative gives me a negative, and I will write my 15x over 1 times 1 over 3x. I will write the other side, 15x over 1 times x over 15. Now let's go through and see what cancels. In this first term, my x's will cancel. My 5 will go into my 15 3 times. I am left with 3 times 2, which is 6, over 1, which is simply 6. Subtract. For my second term, my x's will cancel. My 3 will go into 15 5 times. I am left with 5 times 1, over 1, which is simply 5. Equals, on the other side of the equation, my 15s will cancel. I am left with x times x, or x squared over 1, which is x squared. Please notice that I eliminated the 5 in the x, the 3 in the x, and the 15 by multiplying through by my LCD. My resulting equation would be 6 subtract 5, which is 1, equals x squared. It is a quadratic equation, so I know that I want to set it equal to 0. Let's rewrite it. 1 equals x squared. Let's subtract 1 from both sides of the equation. 1 subtract 1 will give me 0, equals x squared subtract 1. Since it's quadratic, I will factor it. X squared minus 1 is a difference of squares. It factors as x plus 1 times x minus 1. Setting each factor equal to 0, I will have x plus 1 equals 0 and x minus 1 equals 0. Solving the first equation, I will subtract 1 from both sides. I get x equals negative 1. Solving the second equation, I will add 1 to both sides. I get x equals 1. So my solutions for my resulting equation, 1 equals x squared, are minus 1 and plus 1. I need to check to be sure that they are solutions of the original equation. So let's check. We will check x equals 1, and we will check x equals negative 1 in the original equation. I will replace each x with the 1. I will have 2 over 5 times 1 minus 1 over 3 times 1. Does that equal to 1 over 15? For my first fraction, I will have 2 over 5 subtract 1 over 3. In order to subtract the fractions, I need an LCD. The LCD is 15. I will multiply the 2/5 by 3 over 3. I will get 6/15. Subtract. I will multiply the 1/3 by 5 over 5. I will get 5/15. 6/15 subtract 5/15 will give me 1/15, which is the same thing that I have on the other side of the equation. So x equal 1 checks in the original equation. X equal to negative 1, I will have 2 over 5 times negative 1, subtract 1 over 3 times negative 1. Does that equal to negative 1 over 15? My first fraction will be 2 over negative 5, subtract 1 over negative 3. Let's clean up those signs. Positive divided by a negative would be a negative 2/5. I have subtract a positive divided by a negative, which is the equivalent of adding 1/3. Once again, my LCD is 15. I will multiply my 2/5 by 3 over 3. I will multiply my 1/3 by 5 over 5. I will have a negative 2 times 3 is 6 over 15, plus 1 times 5 is 5 over 15. Negative 6/15 plus 5/15 will give me a negative 1/15, and that's what I have on the other side of the equation. So x equals negative 1 also checks in the original equation. So let's write the solution set. 1, negative 1. If you would prefer, you may write plus or minus 1. Problem number 2, solve and check. Once again, I am solving a fractional equation. I want to get rid of my denominators. To do that, I need to find my LCD. I will rewrite my problem. I have x plus 5 over x minus 3, and x minus 3 is a factor in my denominator, equals 2. I will write my 2 over 1, plus I will write my 7 over, once again, my factor in my denominator is x minus 3. When I find the LCD, I have a numerical factor of 1 and a variable factor of x minus 3. So my LCD would be 1 times x minus 3, which is simply x minus 3. I only need to use the x minus 3 to the first power because it's only raised to the first power in each denominator. My next step is to multiply both sides of the equation by the LCD. I will write my LCD x minus 3 over 1. I will multiply it by the fraction on the left, which is x plus 5 over x minus 3 equals, and now I will write my LCD x minus 3 over 1, and I will multiply it by both fractions on the other side of the equation. Now look what happens when I multiply. I will rewrite this side, x minus 3 over 1 times x plus 5 over x minus 3. On the right side, I need to multiply the x minus 3 over 1 by both the terms in the parentheses. I will say x minus 3 over 1 times my 2 over 1. A positive times a positive is a positive, and then I will say x minus 3 over 1 times my 7 over x minus 3. Now, quite honestly, I don't usually put this second step because look, in reality, what happens when I multiply both sides of my equation by my LCD. I end up multiplying each of my fractions in my original equation by the LCD. So usually I just take the LCD and multiply it by each term in the original equation. Now let's see what will cancel. The x minus 3 will cancel the x minus 3. I am left with x plus 5 over 1, which is just x plus 5. On the right side, I have 2 times x minus 3, and for the next term, my x minus 3's will cancel, and I am left with 7 over 1, which is 7. Removing the parentheses in my resulting equation, I will have x plus 5 equals 2 times x is 2x, 2 times negative 3 is negative 6, plus 7. Combining like terms, I will have x plus 5 equals 2x minus 6 plus 7 will give me a plus 1. This equation is a linear equation, so I know I want to get all my x's on one side. I will choose to move this x by subtracting x from both sides of the equation. X subtract x is 0x. I am left with 5 equals 2x subtract x is x plus 1. Now I need to move my 1. I will subtract 1 from both sides of the equation. 5 subtract 1 will give me 4. I have my x on the other side, and 1 subtract 1 gives me 0. So my solution for my resulting equation is x equals 4. Let's check it in the original equation. I will have 4 plus 5 over 4 subtract 3. Does that equal to 2 plus 7 over 4 subtract 3? 4 plus 5 is 9. 4 subtract 3 is 1. 9 divided by 1 is 9. On the other side of the equation, I have 2 plus 7 over 4 subtract 3 is 1. So I have 2 plus 7. 2 plus 7 is 9. Since I have 9 equals 9, that tells me that x equals 4 checks in the original equation, so I will write it as my solution set. X is equal to positive 4. Problem number 3, solve and check. Once again, I am solving a fractional equation. I know I want to get rid of the denominators, so I need to find the LCD. Let's write 3 over x, of course x is a prime factor, plus 2 over x minus 5 is a prime factor, equals 10 over, and when I factor this denominator, I have a common factor of x. When I factor the x out of x squared, I'm left with x. When I factor x out of minus 5x, I'm left with a minus 5. I have my denominators factored. Let's determine the LCD. Let's get each different factor in those denominators. I have a factor of x. I have a factor of x minus 5. Each of those factors is raised to the first power in any one denominator, so I just need to use it raised to the first power in my LCD. Next, I will multiply both sides of the equation by the LCD, but since we have noticed that multiplying both sides of the equation is the same as multiplying each term by the LCD, let's just do that. We will say x times x minus 5 over 1 times the 3 over x plus my LCD x times x minus 5 over 1 times my 2 over x minus 5 equals my LCD x times x minus 5 over 1 times my 10 over x times x minus 5. Now let's see what cancels. In my first term, my x's will cancel. I am left with x minus 5 times 3 plus, in my second term, my x minus 5's will cancel. I am left with 2 times x over 1, which is 2x, equals, on the other side of the equation, the x minus 5 will cancel and the x's will cancel, so I am left with 10. Let's remove the parentheses in my resulting equation. 3 times x is 3x. 3 times negative 5 is negative 15, plus 2x equals 10. This equation is a linear equation. Let's combine like terms. 3x plus 2x will give me 5x. Subtract 15 equals 10. I want to get the x by itself, so I want to get rid of that 15. Let's add 15 to both sides of this equation. the result is 5x equals, of course, minus 15 plus 15 is 0. On the other side of the equation, 10 plus 15 is 25. Let's divide both sides by 5. We get x equals 5. X equals 5 is the solution for the resulting equation. Let's see if it is a solution for the original equation. Let's check x equals 5 in the original equation. We will replace each x with 5. I will have 3 over 5 plus 2 over 5, subtract 5. Does that equal 10 over 5 squared, subtract 5 times 5? On the left I have 3/5 plus 2 divided by 5 subtract 5 is 0. What is 2 divided by 0 equal to? Division by 0 is undefined. Since division by 0 is an undefined operation, the value x equals 5 cannot be a solution of the original equation. Therefore, there is no solution for this equation. We write the empty set symbol or no solution. When you are checking fractional equations, if at any time you have a quantity that is not defined, if you have division by 0, then you do not need to continue to check. You know that the solution you are checking is not a solution for the original equation. This problem emphasizes the requirement that we must check solutions in the original equation. Another important concept emphasized is that whenever we multiply through by an LCD which contains the variable, it is possible that a solution will be introduced into the resulting equation which is not a solution of the original equation. Such a solution is called an extraneous solution. X equals 5 is an extraneous solution for the original equation, and that's why there is no solution for the original equation. I would like to emphasize that whenever we multiply through by an LCD which contains the variable, it is possible that a solution will be introduced into the resulting equation which is not a solution of the original equation. Such a solution is called an extraneous solution. Usually, when we are checking and we have an extraneous solution, we just kind of cross it out to show that it does not check. And if there is no other possible solution, then we write the empty set or no solution. Problem number 4, solve and check. Once again, we are solving a fractional equation. We know we want to get rid of the denominators, and to do that, we know we find the LCD. Let's rewrite this equation and factor the denominator so we can determine the LCD. X minus 4 is a prime factor, minus 1 over. X plus 1 is a prime factor, equals 5 over, and my trinomial denominator factors as x minus 4 times x plus 1. My LCD for this problem would be x minus 4 times x plus 1. Now let's multiply through by the LCD, which means let's multiply each of these fractions by the LCD. Let's write x minus 4 times x plus 1 over 1. Let's multiply it by this first fraction, 2x minus 3 over x minus 4. Subtract, let's write our LCD, x minus 4 times x plus 1 over 1 times our second fraction, 1 over x plus 1 equals, let's write our LCD, x minus 4 times x plus 1 over 1 times our 5 over x minus 4 times x plus 1. Let's eliminate the denominators. X minus 4 cancels x minus 4. I am left with x plus 1 times 2x minus 3. Subtract, x plus 1 cancels x plus 1. I am left with 1 times x minus 4, which is x minus 4. Since the subtraction sign applies to both those terms, I will leave them in parentheses to emphasize that I do have to apply the subtraction to both the x and the minus 4. On the other side of the equation, the x minus 4's will cancel, the x plus 1's will cancel. I am left with 5 over 1, which is 5. Let's remove parentheses. To begin with, I am multiplying two binomials. I will use the FOIL method. X times 2x is 2x squared. For an outer term, x times negative 3 is negative 3x. For an inside term, 1 times 2x is 2x. When I combine negative 3x with 2x, I get minus x for a middle term. For the last term, 1 times negative 3 is negative 3. Applying the subtraction sign to both the x and the negative 4 is like thinking negative 1 times x is negative x. Negative 1 times negative 4 is positive 4 equals 5. Let's combine like terms. I have 2x squared minus x is minus 2x. Minus 3 plus 4 will give me plus 1 equals 5. My resulting equation after multiplying through by the LCD is quadratic. I want to write it in standard form and see if I can factor it. So I know I want to move the 5. I will subtract 5 from both sides of the equation. I will have 2x squared subtract 2x. 1 subtract 5 will give me minus 4 equals 5 subtract 5 will give me 0. Now let's see if we can factor this quadratic equation. First I will common factor a 2 out. I am left with x squared minus x minus 2 equals 0. I will now factor my trinomial. My trinomial will factor, let's see, I need a 1 and a 2. My 2 needs to be negative and my 1 needs to be positive. Using the 0 principle, I know that 2 does not equal to 0, but I will set my variable factors equal to 0 and solve my equations. For my first equation, I will subtract 1 from both sides. I get x equals negative 1. For my second equation, I will add 2 to both sides. I get x equals 2. So the solutions of my resulting equation are x equals negative 1 and x equals 2. I need to check those in my original equation. So I want to check x equals negative 1 and x equals 2. So let's go back to the original equation. We will start with the -1. We will replace each of these x's with a -1. So we will have 2 times -1 subtract 3 over -1 subtract 4 subtract 1 over -1 plus 1. Does that equal to 5 over -1 squared subtract 3 times -1 subtract 4. Let's work with the left. For this first fraction, I have 2 times -1, which is -2. -2 subtract 3 will give me a -5 in the numerator. In the denominator, -1 subtract 4 will give me -5. For my second fraction, I have 1 over -1 plus 1 is 0. Notice, once again, division by 0. What does this mean? This means that x equals -1 is not a solution of the original equation. It means x equals -1 is an extraneous solution of the original equation. We will cross it out. Now we still have a possibility of a solution for this equation, so let's go ahead and check and see if x equals 2 is a solution. Let's replace each of the x's with a 2. I will have 2 times 2 minus 3 over 2 subtract 4 minus 1 over 2 plus 1. Does that equal to 5 over 2 squared subtract 3 times 2 minus 4? Let's work with the left. 2 times 2 is 4. 4 subtract 3 is 1. 2 subtract 4 is -2. Subtract 1 over 2 plus 1 is 3. I have a positive divided by a negative, which is a -1/2. Subtract 1/3. I need to find the LCD, which is 6. I will multiply the 1/2 by 3 over 3 and the 1/3 by 2 over 2. I will get -3/6. Subtract 1 times 2 is 2/6, and -3/6 subtract 2/6 will give me a -5/6. Let's see what I get on the other side. I have a 5. 2 squared is 4. Minus 3 times 2 will give me -6. Subtract the 4. Well, the 4 subtract 4 gives me 0. I am left with 0. Subtract 6 in the denominator, which is just -6. 5 divided by -6 is a -5/6. So x equal 2 does check. So I do have one solution for the original equation, 2, and I will write it as a solution set. Problem number 5, solve and check. I would like for you to solve this equation. After you have worked it, I shall give you the correct solution and shall solve and check the equation. Now please pause the tape and solve the equation. How did you do? Did you find that -1/2 and -1/3 are the solutions for this equation? If so, you may want to fast forward to problem number 6. If not, you may follow along as I solve and check this equation. I am solving a fractional equation. I know I want to get rid of the denominators by finding the LCD and multiplying both sides of the equation by the LCD. I will rewrite the equation 1 over 2 times x squared plus 5 over 2 times x equals negative 3 over 1. When I find my LCD, I look at my numerical factors 2, 2, and 1. 2 is the smallest number that 2 and 1 will go into evenly, so I will use 2 for my numerical factor in my LCD. My only variable factor is x. Since x is used to the second power in this denominator, I will have to use x raised to the second power in my LCD. So my LCD is 2x squared. I will multiply both sides of the equation, or each fraction in the equation, by the LCD. I will write 2x squared over 1 times 1 over 2x squared plus 2x squared over 1 times 5 over 2x equals 2x squared over 1 times negative 3 over 1. In my first fraction, my 2's cancel, my x squares cancel. I am left with 1 over 1, which is 1, plus in my second fraction, my 2's cancel. My x will cancel one of my x's in the numerator, so I am left with x times 5, or 5x, equals, on the other side of the equation, I have 2x squared times negative 3, which is negative 6x squared. I will have negative 6x squared over 1, which is negative 6x squared. My resulting equation is quadratic, so I want to write it in standard form. I will add my 6x squared to both sides of the equation. On the left, writing the left side of the equation in standard form, I will write 6x squared, then my 5x, then my 1. On the right, minus 6x squared plus 6x squared is 0. When I factor 6x squared plus 5x plus 1, it will factor as 3x plus 1 times 2x plus 1 equals 0. Setting each factor equal to 0, I will have 3x plus 1 equals 0 and 2x plus 1 equals 0. Solving the first equation, I will subtract 1 from both sides. I get 3x equals negative 1. I will divide by 3. I get x equals negative 1/3. For the second equation, I will subtract 1 from both sides. I get 2x equals negative 1. Dividing both sides by 2, I get x equals negative 1/2. So the solutions for my resulting quadratic equation are negative 1/3 and negative 1/2. I need to check those in my original equation to see if either of those are extraneous solutions. So let's check. I'll check x equals negative 1/3 and x equals negative 1/2. Replacing each x with negative 1/3, I will have 1 over 2 times negative 1/3 squared plus 5 over 2 times negative 1/3. Does that equal to negative 3? For my first fraction, I will have 1 over. I will write my 2 over 1 times. I will square my negative 1/3. When I square negative 1/3, I get a positive 1/9. For my second fraction, I will have 5 over. I will write my 2 as 2 over 1 times my negative 1/3. In the first fraction, I have 1 divided by. In the denominator, I will have 2 times 1 is 2, 1 times 9 is 9, plus, for my second fraction, I will have 5 divided by. Positive times a negative is a negative. 2 times 1 is 2, 1 times 3 is 3. Now for my first fraction, I have 1 divided by 2/9. which is the same as 1 times the reciprocal of 2/9. The reciprocal of 2/9 is 9/2. For my second fraction, I'll have a positive divided by a negative, which is a negative. I have 5 divided by 2/3, which is the same as 5 times the reciprocal of 2/3. The reciprocal of 2/3 is 3/2. For my first multiplication, 1 times 9/2 is 9/2. Subtract 5 over 1 times 3 over 2. 5 times 3 would give me 15. 1 times 2 would give me 2. 9/2 subtract 15/2 would give me a negative 6/2, and negative 6/2 is negative 3. Negative 3 is what I have on the other side of the equation, so x equals negative 1/3 checks in the original equation. Let's check x equals negative 1/2. I will have 1 over 2 times negative 1/2 squared plus 5 over 2 times negative 1/2. Does that equal to negative 3? For my first fraction, I'll have 1 over, I will write my 2 over 1. I will square my negative 1/2. When I square negative 1/2, I get positive 1/4. Plus, for my second fraction, I will have 5 over, I'll write my 2 over 1 times my negative 1/2. For my first fraction, I will have 1 over, when I multiply the 2 over 1 times the 1/4, I can say 2 goes into 2 once, 2 goes into 4 twice. That leaves me with 1 times 1, which is 1, over 1 times 2, which is 2. Plus, for my second fraction, I will have 5 over, a positive times a negative is a negative. When I multiply 2 over 1 times 1/2, my 2's will cancel. They will leave me with 1 over 1, which is 1. For my first fraction, I have 1 divided by 1/2, which is the same as 1 times the reciprocal of 1/2. The reciprocal of 1/2 is 2. For my second fraction, I have a positive divided by a negative, which is a negative, and 5 divided by 1 is 5. So I have 1 times 2, which is 2, subtract 5. 2 subtract 5 is a negative 3. On the other side of the equation, I also have a negative 3. So x equals negative 1/2 also checks in the original equation. Let's write the solution set. My solution set is negative 1/3, negative 1/2. I would like for you to try problem number 6 also. After you have worked it, I shall give you the correct solution and shall solve and check the equation. Now please pause the tape and solve the equation. How did you do? Did you get negative 3 for the solution? If so, good for you. I shall finish this lesson by solving and checking this equation. I am to solve the fractional equation. I know I want to get rid of the denominators, and to do that I find the LCD. I will rewrite the equation. For my first denominator, I will have a factor of x plus 2. For my second fraction, I will have the 2x over, and the factor in the denominator is 2x minus 1. On the other side of the equation, I have my 4x squared, and when I factor my trinomial denominator, it factors into 2x minus 1 times x plus 2. My LCD for this equation will be x plus 2 times 2x minus 1. I now need to multiply each fraction by the LCD. I will write my LCD x plus 2 times 2x minus 1 over 1. I will multiply it by my first fraction, 3x plus 3 over x plus 2, subtract. Now I write my LCD, x plus 2 times 2x minus 1 over 1 times my second fraction, 2x over 2x minus 1. On the other side of the equation, I will multiply my LCD, x plus 2 times 2x minus 1 over 1 times my 4x squared over 2x minus 1 times x plus 2. Now let's see what cancels. In my first fraction, the x plus 2 will cancel the x plus 2. I am left to multiply 2x minus 1 times 3x plus 3. Subtract. In my second fraction, my 2x minus 1 will cancel my 2x minus 1. I am left to multiply 2x by x plus 2. On the other side of the equation, the 2x minus 1's will cancel, the x plus 2's will cancel. I am left with 4x squared. Now let's remove parentheses. To begin with, I need to multiply my 2x minus 1 times my 3x plus 3. Since I am multiplying binomials, I will use the FOIL method. 2x times 3x is 6x squared. For my outside term, 2x times 3 is 6x. For my inside term, negative 1 times 3x is negative 3x. 6x subtract 3x will give me a positive 3x for my middle term. For my last term, negative 1 times 3 is negative 3. Distributing my negative 2x to my x and my 2, negative 2x times x is negative 2x squared. Negative 2x times 2 is negative 4x equals 4x squared. Combining like terms, 6x squared subtract 2x squared will give me 4x squared. 3x subtract 4x will give me minus x, and then I have my negative 3 equals 4x squared. The resulting equation appears to be quadratic, but when I move my 4x squared over by subtracting 4x squared from both sides of the equation, what happens to my x squared term? (4x squared subtract 4x squared is 0x squared. I have my minus x, my minus 3 equals 4x squared minus 4x squared is 0. Now, of course, we know that anytime we have the same term on both sides of the equation, that they will cancel each other out. My resulting equation is a linear equation. I think the quickest way to solve it would be to move my x. So I will add the x to both sides of the equation. Minus x plus x is 0x. I'm left with negative 3 equals 0 plus x, which is x. So the solution of my resulting equation is x equals negative 3. But I need to check that in my original equation. I will replace each x with negative 3. I will have 3 times negative 3 plus 3 over negative 3 plus 2, subtract 2 times negative 3 over 2 times negative 3, subtract 1. Does that equal to 4 times negative 3 squared over 2 times negative 3 squared plus 3 times negative 3 subtract 2. For my first fraction, 3 times negative 3 is negative 9. Negative 9 plus 3 is negative 6. In the denominator, negative 3 plus 2 is negative 1. Subtract 2 times negative 3 is negative 6. In the denominator, 2 times negative 3 is negative 6. Subtract 1 is negative 7. Let's clean up these signs. Negative 6 divided by negative 1 would be a positive 6. I'm going to write it as 6 over 1 because I have a fraction to combine with it. Subtract, a negative divided by a negative would be subtract, and then I can think the negative divided by a negative would be a positive 6 over 7. To combine these fractions, I need an LCD, which is 7. I will multiply 6 over 1 by 7 over 7. 7 times 6 will give me 42. 7 times 1 will give me 7. Subtract 6 over 7. 42 sevenths subtract 6 sevenths will give me 36 sevenths. Let's see what I get on the other side. I will have 4 times negative 3 squared is 9 over 2 times negative 3 squared is 9 plus 3 times negative 3 subtract 2. 4 times 9 is 36. 2 times 9 is 18. 3 times negative 3 is negative 9. Subtract 2. I have 36 in the numerator. In the denominator, 18 subtract 9 is 9. 9 subtract 2 is 7. So I get 36 sevenths equal 36 sevenths. X equals negative 3. We'll check. Let's write negative 3 as the solution set. This completes the Solving Fractional Equations lesson. Please rewind the tape before you return it. Thank you.